Okay, so I'm going to start recording this from the beginning for those of us who might have missed some of this in class today with my microphone not working this morning because of batteries. So this is an exponential graph, and an exponential graph has a horizontal asymptote at y equal -1. So I'm going to draw that in, y equal -1. And a little reminder with these graphs, they're of the form y equal a times b to the power x minus h plus k. But when I'm really concerned with, my a is 1, my b is 5. So this is my b. In front of my a, there is nothing, so my a is 1. So what that means is when I'm graphing this, I am going to go to where my asymptote crosses the y-axis. And because of this x minus 3, I'm going to go to the right 1, 2, 3. And this is where I'm going to start. And this is where I start with my a. My a is 1. So again, I dropped the graph down because of the asymptote. The x minus 3 meant I moved to the right 3. And my a is 1, so I'm going to go 1 above. Then my b is 5. That means I'm timesing by 5. So as I go over one more, 1 times 5 is 5. I'm going to go up 1, 2, 3, 4, 5. And here is my exponential graph. Okay. Now, to find the inverse, I am going to switch my x and y. And so I am going to have, let me just move this over a little bit. I am going to have x equal, let me make that a little darker, 5 to the y minus 3 minus 1. When I'm trying to get this into y equal form, the very first thing I need to do is get my base to a power by itself. So I'm going to add the 1. Now that I have my base to the power, I can rewrite it in logarithmic form. So this is going to be log base 5 of x plus 1 equals y minus 3. Then the next thing I'm going to do is I'm going to add 3. So I'm going to go log base 5 of x plus 1 plus 3 equals y. And that is going to be my inverse equation. Now, to graph that inverse equation, I can really just look at the original graph and then just do the opposite, meaning switch my x and y. So since this is at y equal -1, I'm going to have an asymptote at x equal -1. Just draw that in. Move this for a second. So this is going to be x equal -1. And then when I'm doing my points, I am going to go and take a look at these points. I have a point at 3, -1. Sorry, 3, 0, apologize, 3, 0. So I'm going to have a point at 0, 3. This point is at 4, 4. So when I flip 4, 4, I still get 4, 4. And there is my inverse graph. Okay, make sure. Okay, so again, this point was at 3, 0. The inverse is at 0, 3. This point was at 4, 4. And the inverse is at 4, 4. So the next one, I have a log this time. And so for this graph, this is going to have a vertical asymptote at x equal -3. Okay, so I'm going to put an asymptote at x equal -3. And then when I'm graphing these, I'm thinking about the following values. Since this is base 7, I'm thinking log base 7 of 1, log base 7 of 7. Well, log base 7 of 1 is 0, and log base 7 of 7 is 1. Log base 7 of 49 would be the next nice one, but that's not going to fit on my graph. Okay, so I'm going to be plotting these points. I'm going to come to where the asymptote crosses the x-axis. This +4 is going to mean that I'm going to be starting up here at a height of 4. So I'm going to come to where my asymptote is at a height of 4. And this is where I'm going to go out 1 and 7 and 49. So when I go out 1, log base 7 of 1 is 0. When I go out 1, 2, 3, 4, 5, 6, 7, log base 7 of 7 is 1. And then I've got my graph. Now I need to do the inverse. And to find the inverse, I am going to switch my x and y. So I'm going to have x equal log base 7 of y plus 3 plus 4. I am going to do like I did with my exponential. I had to get my base by itself. In this case, I have to get my log by itself. So I'm going to minus 4 equals log base 7 of y plus 3. Now I am going to make sure that this looks, here, let me make that y look like a y of y plus 3. Okay, y plus 3. Now I'm going to rewrite this in exponential form. Okay. So this is going to be 7 to the x minus 4 equals y plus 3. Last thing I'm going to do is I'm going to minus the 3. So I'm going to get 7 to the x minus 4 minus 3 equals y. And that is going to be my inverse equation. Now, since my logarithm had x equal -3, my exponential is going to have y equal -3. So y equal -3. And again, I'm going to look at these points. Okay, so this point is at -2, 4. So I'm going to have a point at 4, -2. I'm going to flip-flop. This point is at 4, 5. So I'm going to have a point at 5, 4. And then I'm going to draw my exponential graph. And that's my inverse. Okay. So the next one, we are graphing an a logarithmic graph. This x minus 2 means we have a vertical asymptote at x equal 2. I'm going to be thinking about log base 4 because this is base 4. So log base 4 of 1 and log base 4 of 4 and log base 4 of 16. Now I have a negative in front, and so that negative is going to make it opposite afterwards, okay? So this is going to be 0 times 0, times a negative is still 0. Log base 4 of 4 is 1, and then I make it opposite because of the negative in front. Log base 4 of 16 is 2, and again, because of that negative, I make it opposite. Now the 16 is not going to fit on my graph. Okay, so I'm going to go to x equal 2. I'm going to have my my vertical asymptote here. Get my pen again. Okay. And again, that's x equal 2. Then this minus 5 means I'm going to be coming down here at the height of 5, which is kind of off the bottom of my graph. And where my asymptote crosses that, that's where I'm going to be going out 1 and 4 and 16. So when I go out 1, log base 4 of 1 is 0, times the negative is still 0. When I go out 1, 2, 3, 4, log base 4 of 4 is 1, times the negative is a negative 1. And there's my graph. Now my domain for this graph is going to be from my asymptote out. So that is going to be from 2 out. So it's going to be open circle. It's going to be open bracket 2 to infinity. Okay, because it's going from here at 2 on. Okay, so the next one, another log. This one has x equal -2 as an asymptote. And I'm thinking about log base 5, log base 5 of 1, log base 5 of 5. I would do log base 5 of 25, but it's not going to fit. So log base 5 of 1 is 0. Log base 5 of 5 is 1. Log base 5 of 25 is 2. Okay, so that's what I'm going to plot. So I'm going to get my asymptote drawn. Just going to draw it solid. Okay, so that's x equal -2. That's my asymptote. And then I'm going to go to a height of 3. Okay, so I'm just marking this just as this is the height I'm going to be at. That's not a point. And then that's where I'm going to go out 1 and 5 and 25. So log base 5 of 1 is 0. Log base 5 of 5, 1, 2, 3, 4, 5. Log base 5 of 5 is 1. I go out 25 and I'd go up 2, but that's not going to fit. And here is my log. My domain for this is going to be from my asymptote out. So that's going to be -2 open bracket to infinity. Okay, C. Oh, sorry, 3A. So these ones we're going to be rewriting in exponential form. So this is going to be 4 to the -2 equals x. Anytime you raise something to a negative power, it makes it a reciprocal. So 4 squared is 16. So 4 to the negative square is 1 over 16. And that's your answer. And you'll notice that x is in a different spot in each of these problems. So the next one, again, I write it in exponential form. 8 to the x is equal to 1 over 32. I'm going to get both bases to be the same. So 8 is going to be a 2 to the 3rd raised. So I'm just going to rewrite that. So 2 to the 3rd raised to the power x, so that I can write that as 2 to the 3x. This is going to be 2 to the -5. The negative flips it. The 5 is going to make it a 32. So now that they're the same base, I can set my exponents equal. And so I'm going to get 3x is equal to -5. So x is equal to a -5/3. Okay. Next one. So again, rewrite in exponential form. This is going to be x to the -1/2 is equal to 5. So when I have something raised to an exponent, I want to undo that. I can raise it to the reciprocal because I'm really trying to make a 1, and power to power you multiply. So I'm going to raise this to the -2nd, and I'm going to raise this to the -2nd. Okay. And when I do that, this is going to become x. This is going to become 5 squared is 25, 5 to the negative second, 1 over 25. Okay. Now, next page. So on these ones, we're trying to find the inverse. So I'm going to switch my x and y. So I'm going to write x equal square root of y minus 7 over 3 minus 8. I want to add 8 to both sides. So x plus 8 is equal to the square root of y minus 7 over 3. I am going to square both sides. Now I'm going to leave this as an x plus 8 quantity squared. And when I square this side, it undoes the square. I'm going to times both sides by 3 to get rid of this 3. So this is 3 times x plus 8 squared equals y minus 7. I am going to add 7 to both sides. So this is 3 times x plus 8 squared plus 7 equals y. Now that is my equation. Now the one thing you need to pay attention to when you are doing these graphs is this first one is a square root graph. Okay, so it's a square root graph that looks something like this. And it's going to be starting at 7 comma negative 8. And we only have the top half. We don't have the bottom half. I do not have what I'm drawing in orange right now. I do not have that part. Okay, I only have the top part. So what that means is I have from negative 8 up. So this is for y greater than or equal to negative 8. That's going to give me a restriction. And why do I need a restriction? Because the inverse of because this graph here is a square root graph. And again, I don't have that whole, is a parabola. And I don't have the whole parabola. I'm only getting half of it. And the half that I'm getting is this half. I'm getting this half. That's the half I'm getting. I'm getting the half that was from negative 8 up. Now it's going to be from x is greater than or equal to negative 8. So I'm going to have this restriction. So this is my parabola, but I don't have the whole parabola because I didn't have a whole sideways parabola. I only had the top part, which was from my vertex, which is at negative 8 for my y up. So that means now from this vertex, which is at negative 8 comma 7, I'm going from negative 8 out. The next one's very similar. It is a cube root though, and for a cube root, we don't have to worry about that type of a restriction. So I am going to switch my x and y. I am going to minus 1. Okay. And then I am going to cube both sides. So again, I'm going to have x minus 1 cubed equals y plus 6 over 9. I'm going to multiply both sides by 9. So I'm going to have 9 times x minus 1 cubed equals y plus 6. I'm going to minus 6 from both sides. So I'm going to have 9 times x minus 1 cubed minus 6 equals y. And that's my inverse. Now, when we're dealing with these graphs, my original one is something like this. That's what this x cubed is. Let me move it over. Okay, that's what the x cubed is. or sorry, the cube root is. This one is a cube, and a cube looks like this. And you can see that this, I'm getting both halves. It's not like with my square root where I only have half of the sideways parabola. I don't need a restriction for this. I have this whole entire thing here, and when I make the inverse, I'm going to get this whole entire thing here. So we're good to go on that one. Okay, composition of functions. So we always start from our inside out. Okay, we always start from our inside out. So I'm going to be working out this first. Okay, so I'm going to be working out g of -2, and g of -2 is going to be -2 squared minus 5. That's going to be 4 minus 5, which is a -1. Now I'm going to be taking that and I'm going to be putting that into f. So now I'm going to find f of -1. So 7 minus 3 times -1, which is 7 plus 3, or 10. That is my answer. That's what f of g of -2 equals. Now for the next one, I am going to go through a similar process. I'm going to start with that part first. So I'm going to find my f. I'm going to find my f of x, and I know my f of x. My f of x they gave me, which is 7 minus 3x. Then I'm going to take that, and I'm going to put that into g. So now I'm going to find g of 7 minus 3x, which is 7 minus 3x squared minus 5. Now on something like this, we're going to work it out. So let me just move this up a little bit. So I'm going to work this out. So this is a minus b quantity squared. So I square my 7, I get a 49. I multiply this together, I get a -21x, I double it, I get a -42x. I square my -3x, which is a 9x squared, and then I have my -5. I am going to combine like terms, so I have a 9x squared minus 42x plus 44. And that's my answer. Okay, next one, completing the square. So they want us to get this to be in a nice graphing form by completing the square. So first thing I'm going to do is I'm going to add 15 to both sides. Then I'm going to try to complete this. So I know it's going to be x squared plus 8x plus something. And I'm going to add that same something onto this side. Now to figure out what that is, I am going to take my 8x. I'm going to take half of my b, so that's 4. I am then going to square it. So 4 squared is 16. So I put 16 here and 16 here. Now I'm going to write it as a perfect square. So this is going to be y plus 31. This is going to be x plus, and half of 8 is 4. I'm going to minus my 31, and then I get y equals x plus 4 quantity squared minus 31, and that's my equation. Last two. This one we're going to be finding the the x-intercept. To find the x-intercept, you put 0 in for y, no matter what type of graph it is. So we're going to have 0 equals -9x to the 6th minus 15x to the 5th plus 36x to the 4th. Myself personally, I like my lead here to be positive, not negative. So I'm actually going to bring everything over to this side. So 9x to the 6th plus 15x to the 5th minus 36x to the 4th equals 0. Now I am going to divide everything by 3 because I notice everything's divisible by 3. So 3x to the 6th, 5x to the 5th, minus 12x to the 4th. And when I divide this 0, I also get 0. Okay, so I divided everything by 3. Now, I also have x's, but the x's I'm going to have to factor out. You never want to divide by x because you're going to lose the solution. So the most x's I can take out is x to the 4th. And I'm left with 3x squared plus 5x minus 12 equals 0. So now I am going to factor this. I'm going to do a box to diamond. So in my box, I'm going to put 3x squared here from here. My minus 12 is going to go here. Those multiply to a negative 36x squared, and they have to add to that 5x. So I need this to multiply to negative 36x squared. This also multiplies to the same negative 36x squared, but it has to also add to 5x. So that's going to be a 9x and a negative 4x. 9x and a negative 4x. And then I'm going to find the outside. So this is going to be a 3x and an x. Let me see, I think I have to move this over a little bit. Okay. This, let me see if I can. Here, I'm just going to move this over. Sorry. So again, this was my 3x squared. This is my negative 12. This is a 9x. This was a negative 4x. And so my outside, this is going to be a 3x and an x. X times a negative 4, 3x times a 3. And so I've got for my factors, don't forget I have this x minus 4, x to the 4th, times a 3x minus 4 times an x plus 3 equals 0. So this is going to give me x equals 0. That's one x-intercept. This is going to give me x equal 4/3. And this is going to give me x equal negative 3. Okay, sorry. So x equals 0. Set this is 4/3, and this one is x equal negative 3. Okay, last one. So this is one of those let u equal. So I am going to let u equal the square root of x minus 5. Okay, that's what u is going to be. So I'm going to rewrite this as 2u to the 3rd, 16, 9u. Now I'm going to try to get both of these to be 2 to a power. So it's going to be 2 to the u to the 3rd. My 16 is a 2 to the 4th. And that is being raised to the 9u. And power to power, we multiply. So I'm going to get 2u to the 3rd equals 2 to the 36u. I set my exponents to equal to each other when my bases are the same. So I'm going to get u cubed equals 36u. I'm going to get everything on one side. U cubed minus 36u equals 0. I'm going to factor out a u, and I get u squared minus 36 equals 0. And this is where you want to recognize difference of two squares. So I'm going to get a u times u plus 6, u minus 6 equals 0. Okay, so then I'm going to get u equals 0, negative 6, and 6. That's what u is. So I need to find x though. So now I'm going to solve for x. Okay. So for this one, I know that the square root of x minus 5 equals 0. So when I square both sides, I get x minus 5 equals 0. So x equals 5. That's one answer. Now, when I do that, when I do that with my negative 6, and I take the square root of x minus 5 equals negative 6, I cannot have a square root, a principal root equal a negative, so that is going to be no. So the last one, I am going to take square root of x minus 5 equals 6. I'm going to square both sides, so I get x minus 5 equals 36. And that's going to give me x is equal to 41. So I get x equal 41. I get x equal 5, and those are my two answers. So hopefully you find that helpful. Tomorrow we're going to have D-Day 2 in class that's like this, and then D-Day 3 for homework.